Okay, so let's talk about our unit circle. I brought a white one onto the board just so I could draw on it a little bit easier. And I wanted to just take a look at it a little bit and notice the things that are on there. You got your common angles. We've got our 30-degree angle. We've got our 60-degree angle, our 45 and our 60. Some of the common ones. And you can keep counting all the way around the circle till you get to where 330 is here, and then 360 would be where 0 would be. So those are just some of the common angles that you'll see, but there's a reason why we call this the unit circle. And we talked about that on Friday. We don't call it the awesome trig circle, even though it is awesome. We call it the unit circle. There's a reason why it's called the unit circle. Do you remember why? Friday.
Because it's 1 unit long.
Okay, and it's mentioned again. What was it?
It's 1 unit long.
It's 1 unit long each radius. Okay, the radius is always going to be 1 unit long. So when you go from the center to anywhere on the circle, you're going to get 1 unit. So if I was to do that, both of those lines are represented by 1 unit in length. Now, when you make your unit circle, you might make your 1 unit be 7 centimeters or 8 centimeters. So that's going to represent your 1 unit of measure on your unit circle. Now, if I was to drop a line straight down here and make a right angle, you would see a right triangle there. Okay, that is a 30, 60, 90 right triangle. Because I went to the 30-degree angle, that means this angle right here is 30. And the top angle then is going to be your 60 and then your 90. Now, I want to review and recap with you because I told you, I warned you in advance that those 2 special triangles that we learned in 9.2, the 30, 60, 90, the 45, 45, 90, will be back in trig. You will see them all over this unit circle right here. So I want to recap with you those 2 little triangles and their formulas. In the 30, 60, 90 triangle, we said that your hypotenuse equals your short leg times 2. And we said that the longer leg equals your shorter leg times radical 3. That was the two formulas that we learned for the 30, 60, 90. In the 45, 45, 90 triangle, we know that there's 2 equal angles, so we know we've got 2 equal legs. I'm hoping you're paying attention because this is really going to come in handy. And if you're messing up on your quiz, it's on you for not paying attention. So it's up to you. I'm looking around and I'm hoping you're looking online and looking at the notes and not looking on other stuff on social media and stuff. I really hope that because that's not going to help you at all. So your 45, 45, 90 triangle, we had one formula, your hypotenuse equals your leg. It was not a short leg or a long leg because it was the same leg. They're 45-degree angles. Your leg times radical 2. Leg times radical 2. So let's look back at this triangle now. We've got a hypotenuse in this triangle that's a 1. So if I put this right here, we know that's a 1. Out of those 3 lines in that triangle, we know one of the values. It's a 1, and the hypotenuse all around the circle is always going to be 1. I can bring down a line on any one of those points, and the hypotenuse of that triangle will be a 1. Now, if I look at my little formulas here, and now I know my hypotenuse is a 1, and I want to find my short leg, all I have to do is divide both sides by 2. And my short leg is a half. So on this triangle, you could see that we went up 1/2. So when you have this unit circle, this triangle that you draw in is helping you find these coordinates. These coordinates represent a 30, 60, 90, the sides of a 30, 60, 90. So my hypotenuse was 1, but my y value is 1/2. I could put equals your y value right there. And it's going to be your y value. So my x value is the long leg. In that triangle, this bottom one is longer than the 1/2. It's the long leg down there. That's my x value. I know again, I just found out my short leg is 1/2. So 1/2 times radical 3 is going to be my longer leg. So if I put a 1 under this, you're going to get radical 3 over 2 when you multiply together. So you can see that this side right here is going to be radical 3 over 2. And that's how they got this coordinate right here. Both of those points that I just found, both of those sides of that triangle are in that coordinate. So radical 3 over 2 and 1/2 is the coordinate that you would have at your 30-degree angle, or we could also call it a pi over 6 angle. We'll talk about radians here in a minute. Now I want to look and think back to sine and cosine and tangent. So when we talked about sine earlier, we said it was opposite over hypotenuse. That's our SOH. In the triangle now, we know that the hypotenuse is always going to be a 1. On this circle right now, the hypotenuse is always going to be a 1. So that means that your sine value is basically going to be your opposite side divided by 1, which is just your opposite side. Whenever you divide by 1, it stays the same. So your sine is your opposite side. If this is my angle right here, then my opposite side is 1/2. You could actually put the word sine right above the 1/2 because your sine is going to equal 1/2. Your sine is going to always be your y value because your hypotenuse in this unit circle is always a 1. So it's going to be your y value divided by 1, which is just y. So your sine on the unit circle, your sine is your y value. So if I want to know what's the sine of 120 degrees, I'm going to say it's radical 3 over 2. I don't even have to do my calculator. I don't have to look at anything. If I know my circle and I know it's 120 and I know it's the y value, there's my sine. So what's the sine of 5 pi over 3 down here? What's the sine at 5 pi over 3? What's my y value? Adam, what do you think? Sine of 5 pi over 3. That's what I'm talking about. You guys want to do well on this test. You want to do well on everything, but you don't want to pay attention. It's really difficult to do well if you're not paying attention. Really difficult. Okay, 5 pi over 3. The sine value is going to be your y value, negative radical 3 over 2. You know, if you're not paying attention, I'm going to call on you. It's just the way it is. So either pay attention or get called on. It's one or the other. All right, so sine is your y value. Your cosine is going to be your x value because your cosine is your adjacent over your hypotenuse. Adjacent over hypotenuse. And we know in this unit circle that our hypotenuse is a 1. So it's just adjacent divided by 1, which is adjacent. So my cosine is going to be this side down here, the adjacent side, which is my x value. So above every little x value, we could put cosine. So this one would be a cosine, comma, sine. This one would also be cosine, comma, sine. They would all be sines and cosines. Even this top angle, this pi over 2 angle, is still going to be a cosine and a sine. Cosine, comma, sine. That 0 is your cosine, that 1 is your sine. Same thing for this very first one right here. Cosine is a 1 and sine is a 0. Now I would encourage you to grab a calculator and try this because it will make more sense if you see it in your calculator. If you grab your calculator and you try to put in the sine of 0 degrees, because this is a 0 degree angle. If you grab a calculator and put sine of 0, sine of 0 and it equals, you're going to get 0. Now you should be in degree mode at the moment. We're going to be in radian mode later. So you're going to need to learn how to change modes on this too. If you put in cosine of 0, because you're at 0 degrees, if you put in cosine of 0, you're going to get 1. Cosine of 0 is 1. Because the calculator knows at 0 degrees, your x value is a 1 on the unit circle. So your cosine of that 0 degree angle is you're going to have an adjacent of 1. You don't have an opposite because it doesn't go up. But you do have an adjacent. You have an adjacent of 1 unit. You do not have an opposite. So cosine of 0 is 1. Now you try the top one. Cosine of 0 is going to be, so if you put it, cosine of 90, try 90. So cosine of 90, and that should be a 0 because your cosine is your 0, and it is. Cosine of 90 is a 0. If you put in sine of 90, you get your 1, which is your y value up there in the unit circle. So all the way around the unit circle, whatever your x value is, that's going to be your cosine. Whatever your y value is, that's going to be your sine on the unit circle. Now, these are all decimals, of course. This 1/2 is 0.5. This is actually 0.866. So this would be 0.866, and this would be 0.5. This would be 0.707. There's two of them there. And then this top one is just the 30-degree angle switched around. So you can see those. But those are just going to be decimal values. You can make them decimals. You can leave them as radicals. They're more accurate if you leave them as radicals. That's why they leave them as radicals around the circle. But if you go to a computer one and you actually do an interactive circle and you move it around, it's going to be all in decimals. Like we did on that other website the other day. It showed you all of them in decimals. All right, so that would be your first one. Let's look at your second triangle. Okay, let's draw this one in red. Okay, I'm going to bring a line straight down from the pi over 4 angle this time. Okay, make that a right angle. Make your hypotenuse a 1, because the hypotenuse is always a 1. Okay, so you're going to be thinking about your coordinate there as radical 2 over 2 and another radical 2 over 2. Why are they the same? Why are the x and the y value the same exact value? What do you know about this triangle right here? We know it's 45 degrees, but what happens in a 45, 45, 90 triangle? I see two angles that are the same, 45 and 45, but what happens when you got two angles the same? You got two of the same sides too. So that means my opposite side and my adjacent side are going to be the same. They're both going to be radical 2 over 2. So that means that your sine is radical 2 over 2 because that's opposite. Your cosine is radical 2 over 2 because that's adjacent. They're the same in a 45, 45, 90. When that triangle comes, you know you're going to have the same two numbers. Now in this quadrant, quadrant 1 right here that we're working in right now, this whole quadrant, everything is positive. Everything is positive. We're going to talk about the other quadrants in a second. But let's draw in the last of our 3 triangles. So let's bring this straight down here. Okay, this is a 30, 60, 90 again. It's just the same exact triangle as the blue one, but it's flipped around. It's flipped so that your 60-degree angle is down here at the is here. So this is now your 60-degree angle. And your 30-degree angle is the one that's up near the top. And so basically what happens is it takes this first coordinate that we had and it switches them around. Now your x value is 1/2 and your y value is the radical 3 over 2. So now your opposite is the radical 3 over 2, which is the y, and the adjacent is 1/2. So it takes this first coordinate right here and it switches these two around, and that's what this one is. So that's 30, 60, 90, the other direction. Now you can see how they go all the way around, because in the second quadrant, to get to a second quadrant, you need a negative for your x value, but you still need a positive y value because you're going up still. So you're going up means your y value is still going to be positive on all these. Those y values are still all positive because you're going up. So that means your sine values are all positive. I mean, try it. Take your calculator and put in sine of 120. Just get it in there and check it out, and it should still be a positive number. Sine 120. And you get that 0.866 number. Okay, but if you were to put in cosine of 120, then you're going to not get a positive. Now, you put in cosine of 120, you're going to get a negative 0.5 because it knows, the calculator knows you're now in quadrant 2. And to get to quadrant 2, you had to do a negative x value, and your x is cosine. So it had to go over the negative x value and the positive y value. To get to quadrant 3, they're both negatives. So if you put in the sine of 210 or the cosine of 210, either way you're going to get negative values. Your cosine is still your x, your sine is still your y value. And then to get to quadrant 4, they're going to be a positive value and then a negative value. So your cosine is going to be a positive. If you put in cosine of 330, you're going to get the positive. But if you put in sine of 330, you're going to get the negative a half. Well, one thing we didn't talk about, though, was tangent. Think about tangent right now. Tangent means, okay, tangent, let's go back here, tangent means opposite over adjacent, TOA, T-O-A, SOHCAHTOA, and then TOA. Okay, well, opposite side, the opposite side was our y value. When we're looking at this blue triangle, the opposite side was the 1/2, or the y value. The adjacent side was the radical 3/2, or the x value. So technically, the tangent is going to be the y value over the x value. And on our unit circle, we know the y value is our sine, and we know the x value is our cosine. So if you take your sine and divide it by your cosine, you're always going to get a tangent. Unit circle proves that. That when you have the opposite side over the adjacent side, your opposite was sine, your adjacent was cosine, you divide them, you get tangent. So that's a good one to know. Now, let's look at the radians real quick. Let me use a different color here. So let's look at our radians. This is what we've been talking about for a long time, this pi and 180. Okay, we've been looking at that. That's our conversion ratio. Pi is 180 degrees. Pi is 180. That's how we convert it. If it's going 2 radians, you go multiply by pi over 180. If it's going 2 degrees, you multiply by 180 over pi. So 180 is pi radians. So when you want to take this half a circle and break it up into pieces, you can break it up into 1/6, 2/6. We wouldn't leave 2/6. 2/6 you would reduce to 1/3. So I'm just counting by sixths. 1/6, 2/6, 3/6 would be 1/2. You wouldn't leave 3/6. 4/6 you wouldn't leave, or you would change to 4/6 to 2/3, and then 5/6. 6/6 is the same as 1 pi. So I counted 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. I could even keep going to 7/6. 8/6 would be 4/3. 9/6. 10/6 would be 5 pi over 3, and 11/6 would be right next to 2 pi, which is 12/6. 2 pi right here, this is going to be 2 pi radians, or you could change it to 12 pi over 6 if you're doing by sixths. So you're counting it by how much it's broken, how much we break the 180 into. If I'm going by a 30-degree angle, we're going to be going by sixes, because there's 6 30s and 180. If I went by 1/4, 1/4, 2/4 is the same as a half. 3/4, and then 4/4 is 1 whole. And then you could keep going. 5/4, 6/4, 7/4, 8/4. You're just counting by fourths. There's 6/4. You reduce it to 3/2. There's 7/4. 8/4 would be 2 pi. You could even count by thirds. 1/3, 2/3, 3/3, 4/3, 5/3, and then 6/3 is 2 pi. You're just breaking it up into your pieces. Those are in terms of pi. What I like about the colored circle, though, is you also get whole radians. You don't just get pi radians. You get where 1 whole radian is. That's that 57.3 degrees. And then you get where the two radians is and where 3 radians is. These radians are all broken up in terms of pi. You're breaking up your pi into the different pieces. We know pi is a half a circle, so you're breaking the half a circle into sixes, or into fourths, or into thirds, or in half. So that's how this circle works. The other one actually shows you both. It shows you the pi radians, and it shows you the whole radians on that one. Yep.
Where'd you get tan from? Like, I understand the cosine and the sine.
Okay, so tangent, we got to go back and think of what it actually means. Tangent means your opposite side over your adjacent, TOA, so-called TOA, right? So tan is opposite over adjacent. So my opposite side in the triangle, so look at the blue triangle, the opposite side was a half because that was going up. And going up is always your y value. So your opposite is y, your adjacent is going to be your x value. It's going to cross. So my tangent was my opposite y over my adjacent x, opposite over adjacent. Well, we know that the sine is always going to be your y value and the cosine is always going to be your x value because the hypotenuse is always a 1. So because of that, that makes tangent take sine divided by cosine and you get your tangent.
Oh, okay.
So your y value was your opposite. Oops, just erased it. Your y value was your opposite, your x value was your adjacent. And so if you're going to take your opposite over adjacent, TOA, it's going to be sine over cosine to get tan. Sine is opposite, cosine is adjacent. And they're both hypotenuses of 1, so that's not going to divide, it's going to keep it. All right, let's move on. Move on. Here's what you're going to need for your homework. So you might want to write these things down, and they're all blurry right now, so that's kind of weird. Let's see. Let's refresh the screen. Maybe that will help. And we've got 3 new ones. I don't know if you noticed there, but there are 3 new trig functions. These are the 3 buttons you have on your calculator. You know what sine is? It's your opposite. It's your opposite over your hypotenuse. Your cosine is your adjacent over your hypotenuse. And your tangent we know is opposite over adjacent. Those are the 3 that we've already learned. That's your so-called TOA right there. There's 3 new ones. There's 3 what we call reciprocal functions. There's not a button on your calculator for them. But there is a way to put them in your calculator. We'll show you that at the end. But the cotangent is reciprocal to tangent. So if tangent is opposite over adjacent, then cotangent is going to be adjacent over opposite. You could also call it 1 over tan, because 1 divided by tangent will be your cotangent. 1 divided by anything is reciprocal. You're just taking its reciprocal. Secant is going to be reciprocal to cosine. So it's going to be hypotenuse over adjacent. And your cosecant is going to be reciprocal of sine. So it's going to be the hypotenuse over the opposite. Your secant, you could just put 1 over cosine. Your cosecant would be 1 over sine. Now that's easy to get confused because cosecant sounds like it should go with secant or cosine. Sine kind of sounds like it should go with secant, but it doesn't. Sine goes with cosecant. Both pairs have to have a co in there somewhere. Sine, cosecant. Cosine goes with secant. They both have 1 co in it. Tangent, cotangent. But here's what they're going to ask you on your homework. Part of it. So you want to make sure you can use your unit circle, find it, and solve it. Okay, so on 5 or 6. So if you go back to your unit circle, if you look at it, you could have actually been filling it in on your doodle notes on the back as you were looking at the ones that I was looking at here. Pi over 6, the coordinate was a radical 3 over 2 and 1/2. We just saw that right here, radical 3 over 2 and 1/2. So what we want to do on this first one is put radical 3 over 2 and 1/2. Radical 3 over 2 1/2. So our sine is our y value. Everywhere you see sine for a while, I would just put y on top of it to get used to it. You need to just know right off the bat that sine is your y value. So I don't need to put in my calculator sine of pi over 6 radians. I already know it's going to be whatever the y is. It's a half. So I can just put a half right there. And my cosine is going to always be my x value, so it's going to be radical 3 over 2. Your tangent, however, is your sine over your cosine, your y over your x. So you're actually going to need to take 1/2 and divide it by, because this is my y, this is my x. I'm going to have to divide it by radical 3 over 2. But we can't leave a division problem sitting there. We actually have to change that to a fraction. So we got to actually multiply by the reciprocal here. So I'm going to take the top one and I'm going to multiply it by the reciprocal, which would be 2 over radical 3. So these 2's will cancel, and I'll get an answer of 1 over radical 3. Again, that's not a good answer because it's got a radical on the bottom. So you're going to need to change that, multiply by radical 3 on top and bottom. So radical 3 over 3 is your actual best answer for tangent. Cosine was easy, it was just our x value, and sine was easy, it was just our y value. But the tangent was a little more work because you had to do your sine divided by your cosine. These would be a good thing to have on your paper right now. I don't know, maybe you aren't doing that, but I would do that if I was you. Your cosecant, we're going to do the reciprocal of sine. It's going to be 1 over your y value. Okay, so it's basically 1 over the 1/2. But whenever you put a 1 on top of something, it's just its reciprocal. So you would just put 2. Your answer to that's going to be a 2. It's a reciprocal of sine. Reciprocal of sine. Secant is going to be 2 over radical 3 because it's going to be reciprocal of cosine. And you're going to need to get rid of the radical 3 on the bottom, so you'll get 2 radical 3 over 3 is your secant. 2 radical 3 over 3. Your cotangent, I would put 1 over x on top of that, just so you get used to it. Secant is going to be 1 over the x value. It's always going to be the reciprocal of cosine. Cotangent is going to be your x over your y value. It's going to be your radical 3 over 2 over 1/2. But we're going to multiply by the reciprocal, cross out those, and you're just going to get a radical 3 for your cotan. So there's your 6 trig functions just by using the unit circle and no calculator. Once you find the coordinate, you can use that coordinate to find your sine values, your y, your cosine is your x, and then you can just do your division problems. So looking for it on the unit circle. The letter B is 5 pi over 4. So you would actually need to go to the unit circle unless you know what 5 pi over 4 is. 5 pi over 4 is right down here in the third quadrant, and it's this coordinate down here. They're both negative, and they're both radical 2 over 2's. That's where 5 pi over 4 is. It's actually 225 degrees. If you were using degrees, it would be 225. So they would both be negative radical 2 over 2's. Both of them would be negative radical 2 over 2. So that's easy for sine. Your y value, just put a y above that, negative radical 2 over 2. Your cosine is your x. That's also negative radical 2 over 2. Your tangent is going to be your y divided by your x. So negative radical 2 over 2 over negative radical 2 over 2. But what do you get when you have two things on top and bottom? They're exactly the same. You cancel out, you just get a 1. Doesn't matter if they're both negative. Negative divided by negative is a positive. That's going to be a 1. Guess what cotangent then is going to be? X over y is going to be the same thing. When you reciprocal a 1, you're going to get a 1. Tangent is reciprocal of cotangent. So when you flip a 1 over, you're still going to get a 1. If you took these two fractions right here and flipped them around, it wouldn't matter. You're still going to have negative radical 2 over 2 over negative radical 2 over 2, so it's still a 1. So that would be the cotangent. Now, it's cosecant, though, you're going to need to flip this one around. Negative 2 over radical 2. So you're going to need to get rid of the radical 2. Negative 2 radical 2 over 2. And then you can cross out the 2's. So you're just going to get negative radical 2. But the great thing is secant is exactly the same as cosecant because they're both cosine and sine were the same. So this negative radical 2 is going to come in your answer here as well. So there's your 6 trig functions of letter B there. You can find, as long as you can find your coordinate, your x and the y value, you won't need to put any of these. Now, could we make all these decimals? Could I have taken my calculator? Okay, let me show you something. Here's my calculator. And that's in radian mode, 5 pi over 4 radians. So I'm going to take it and I'm going to hit this DRG button and I'm going to go over to radians and it equals. And then I'm going to put sine of 5 pi over 4. I'm going to hit the sine. I'm going to put 5 pi divided by 4 into parentheses and hit equals. And I get negative 0.707. I get negative 0.707. If I was to take the radical 2 and divide it by 2, I would also get the negative 0.707. That is that exact same fraction. But I don't have to use a calculator, or if I don't have a calculator, I know where it is on the unit circle so I can find it. The sine is always your y value, the cosine is always your x value. Now these bottom two are the easiest ones because there are going to be some zeros in here. Okay, so if you look at it, our 0 point, when your angle is 0 radians, your coordinate would be over 1 and up 0. At 0 radians on your unit circle, when you're right here at 0, your coordinate is the point 1, 0. So you've got a coordinate of 1, 0. So you've got your x value is 1, your y value is 0. We know sine is our y value, so that's a 0. We know cosine is our x value, so that's a 1. If you put in your calculator sine of 0, you're going to get 0. If you put in cosine of 0, you're going to get a 1. When we get a tangent, you're going to need the y value divided by x. 0 divided by 1 is still 0. 0 on top is always going to equal a 0. Cosecant, though, is reciprocal. That would be 0, or that would be 1 over 0. Ooh, what is 1 over 0? Not 0. Not 1. It's undefined. You cannot have a 0 on the bottom. You're not allowed to divide anything by 0. You can't take something and divide it by 0 and expect to get it as a result. It doesn't happen. So that can't happen. Secant, we reciprocal 1, we get a 1, and cotangent, then again, is undefined. You can't flip 0 over. Once you've got a 0, you cannot do a reciprocal of it. And pi is the point negative 1, 0. On your unit circle, if you looked over at pi, you'll see the point negative 1, 0. Your x value is negative 1, your y value is 0. So sine is 0, cosine is negative 1, tangent would be 0 over negative 1, which is 0. So that's your y, that's your x, that's your y over x. Your secant would be 1 over the y value, so it's going to be undefined because you can't flip the 0 over. Cosecant is 1 over your x value, which is still negative 1. And cotangent is x over y, which is undefined. So you just look for the coordinate, and then the x is always your cosine, the y is always your sine. And you'll have all your trig functions that you need. This next little chart has a different one on there for you. So what happens when the angle that we're looking for isn't on our unit circle? It says negative pi over 3. What happens when it's a negative pi over 3 radians? Well, where was positive pi over 3? Where was positive? Here's 0 radians. Positive pi over 3 is right here. Positive pi over 3. So that's at 60 degrees. Well, how do I do negatives? What? Flip what? Negative. Don't flip the fraction. Nope. What do you do to get a negative pi over 3? This is a positive pi over 3. Because I went up to get there. How do you go negatives? Negatives are down. So that's negative 30, that's negative 45, that's negative 60 right there. This is going to be negative pi over 3 radians. It's coterminal to a positive 5 pi over 3. They're going to have the same angle. They're both going to start at 0 and end here. Whether it's straight down to it or whether it's this direction would be the positive 5 pi over 3. Straight down would be a negative pi over 3. So we're still looking at this coordinate right here. Both angles have that coordinate, positive 1/2 and negative radical 3 over 2. So positive 1/2, negative radical 3 over 2. Positive 1/2, negative radical 3 over 2 is your coordinate. So here's my x value, that's the cosine. There's the y value, that's the sine. Sine is negative radical 3 over 2. Cosine is 1/2. Tangent is going to be the y, so sine was y, cosine is x. Tangent is y divided by x. So negative radical 3 over 2 over 1/2. I'm going to change it to a 2 over 1. Cross cancel, that's just going to be a negative radical 3 for my tan. So there's my first 3 values. Because it was this coordinate, so I'm going to get these 3 values. Cosecant, you're going to need to flip the sign over, so negative 2 over radical 3. But you got to fix that because we don't want a radical on the bottom. Negative 2 radical 3 over 3. Secant is going to be the reciprocal of your cosine, so that's going to be a 2 over 1, which is just 2. And then we want to flip the cotangent over to 1 over negative radical 3, so you got to get rid of the radical. Negative radical 3 over 3 will be your cotangent. So those are your 3 here. Now this diagram is showing you that your sine value and your cosine value are going to always stay between 0 and 1. And then it comes back down to 0, and then it goes down to negative 1, and then it goes back up to 0. So actually the sine and the cosine are going to always be between negative 1 and positive 1. So they start at 0. Here for sine, they go up to 1. They come back down to 0. They go down to negative 1. So the highest they get was positive 1. The lowest they get was negative 1. They'll never go above positive 1. They'll never go below negative 1. Same thing with the x value. Positive 1 is the biggest and negative 1 is the smallest. And you'll stay between those two at all times. And let's see, last couple real quick. Let's see, use period as an aid here to help. Because right now, 13 pi over 6 is not on the circle, so I don't know the quadrant or the coordinate. So what I could do is I could subtract a circle. I could subtract a rotation, subtract 2 pi, which I'm going to make 12 pi over 6 because it's got a common denominator to the 6, which 13 pi over 6 minus 12 pi over 6 is going to give me negative pi over 6. No, not negative, positive, sorry. Positive pi over 6. That is on my unit circle. Pi over 6 is right here. It's our coordinate of radical 3 over 2 and a half. Radical 3 over 2 and 1/2 at pi over 6 radians. Radical 3 over 2 and 1/2 is that. Now what I did here is I took this original angle, which is not there, because when you count by 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, 12, 6, 13, 6 is around all the way around to here. So all the way around, that's going to be your 13 pi over 6. Okay, that's 13 pi over 6 all the way around. But what we want is to find out the coordinate on the unit circle. So it's the same as just going straight to pi over 6. They're the same angle. They both started at 0 and they both ended there. That means they both ended at that coordinate. So we knew that this was our x value and this was our y value. So we want to find the sine. The sine is your y value. So sine of 13 pi over 6 is going to be 1/2. So if you tested that in your calculator, if you went into radian mode in your calculator, make sure it said radians at the top, and it's sine 13 pi divided by 6, and you hit equals, you're going to get your 0.5, which is a half. Okay, because it knew that ended at that coordinate right there. Negative 7 pi over 2, you're going to want to add 2 pi, which is 4 pi over 2. So that's going to give you negative 3 pi over 2. I would add another 4 pi over 2, another 2 pi. And when you combine those two, you're going to get a positive pi over 2. That one is way up here at the top, which is the 0.01. And we want cosine. Cosine is your x value. So we want cosine. So the cosine of negative 7 pi over 2 is going to be a 0 because it's that coordinate right there. When we find that negative 7 pi over 2 is the same as regular pi over 2, that means we have to use that coordinate. That means your cosine of that angle's got to be a 0. So there are going to be some where you're not going to be allowed to use a calculator. You're going to have to find them on the circle and see if you can find out 7 pi over 2. Cosine of this negative 7 pi over 2 has got to be a 0 because it's going to be this coterminal angle, the pi over 2. Now the last two are just how do you put it on in your calculator. You're going to have a couple on the homework where you just put them in your calculator. And you got to make sure you're in radian mode. So the first one will be easy. Sine of 2 pi over 3, 2 pi divided by 3 equals, you'll get your 0.866 there. It's the second one that's hard because we don't have a cotangent button on our calculator. Your calculator only has sine, cosine, and tangent buttons. So how do I put a cotangent in here then? There is no cotan button. Well, what we do know about cotangent is that it's 1 over tangent. So what we want to do on this one is put 1 divided by tan of 1.5. If you put that in your calculator, not just tan of 1.5, you actually have to hit 1 and divide it by first. 1 divided by and then hit tan of 1.5. That'll give you a cotan. 1 divided by tangent is the same as cotangent in the calculator. So when you hit equals, you should test that. It's going to be 0.0709. 0.0709. All right, that's all of the notes for 1, 2. Now we'll do some other activities on the unit circle and then you'll do your project. So hopefully it'll start to fall into place how you count, how you get the radians, how you get degrees, how you can go negatives, how you can, from your triangles, the triangles are giving you these coordinates right here because we drew in those triangles. So those are all things that you would add onto your circle project. You color code things and say how they worked. All right.